Hello everyone, welcome to the class once again. I hope you're all doing good and you're the best of your health. In present exercise, we'll be practicing question on mechanical properties of fluid based upon JEE Advanced pattern questions. In your JEE Advanced examination, the question asked are of single choice, more than one choice correct, integer type and even assertion reason, and you'll be having question based upon matrix match. In this exercise, we have discussed question of single choice, more than one choice, assertion reason and integer type. And you may be also having passage based question. Let's go ahead with the first question of the day, and I believe that you'll be ready with all the concepts that you have learned in this chapter, that is mechanical properties of fluids. Let's go ahead with the first question. Question number 1. A uniform cylinder of length L, so you have a cylinder whose length is given as L and mass M, having a cross-sectional area A is suspended with its length vertical from a fixed point by a massless spring such that it is half submerged in a liquid of density sigma at equilibrium position. That means the cylinder is hanging with the help of a spring and it is half suspended in a liquid of density sigma. The extension x naught of the spring when it is in equilibrium is A mg by k, B mg by k 1 minus L A sigma by m, C mg by k 1 minus L A sigma by 2m, and D mg by k 1 plus L A sigma by m. Now if you see the options, it's very difficult for us to judge which option will be actually matching with the right answer. One thing you can do, you can check dimensionally also, but that will be difficult for you all to reach to the result, because everywhere that I think that dimensionally each of the option will be correct. So which option to choose, you have to accordingly you have to solve with each of these steps. This is a question which has been asked in your previous year examination of JEE. So let's go ahead and let's approach with each step that will be involved in solving this. See that it's a uniform cylinder of length L, its length is given, mass M is given, having cross-sectional area A is given, suspended with its length vertical from a fixed point by a massless spring such that it is half submerged in a liquid of density sigma at equilibrium position. Now see the K that has been given, that is the spring constant K that has been provided to us. Let me show you the scenario how you should approach. You have a spring. With this help of a spring, you have suspended a cylinder, and this cylinder is being suspended in a liquid half submerged in a liquid of density sigma. So let me show you that it is half submerged. And now it's in equilibrium. This part is the entire part of the cylinder. So let me show you cylinder differently. Now see that the things that has been provided to us, it says that the density of the liquid is given as sigma, and now the extension in this spring that we need to comment on. You see this question, the extension x naught of the spring when it is in equilibrium is, let's say the extension produced is x naught. Now that means an upward force will be acting on the cylinder that will be equal to kx naught, which we know, and spring on being stretched, it will apply an upward force that will be given as kx naught. Next thing you see, it's half submerged. That means half of its volume will be submerged. That will be buoyant force applied on this solid object will be due to the half volume of the object that is submerged. Now see that if I talk about half length, this half length will be equal to L by 2. Total length is L. You see that with its length vertical from a fixed point by a massless spring such that it is half submerged in liquid of density sigma. Now you see here what you need to apply. First of all, let me show you here net upward force. You have to see net upward force will be equal to the weight of the cylinder. So weight of the cylinder will be equal to net upward force. This is what we can actually make out from the diagram and from the given condition, net upward force. Now weight of the cylinder that's acting, that is equal to mg. Weight will be equal to mg, quite simple, is equal to net upward force kx naught acting along the upward direction plus you should also add the buoyant force that is acting. Buoyant force is acting only due to half volume, that will be equal to L by 2 length multiply with area, that will give you volume, into density, that is sigma, into gravity, that is g. We need to find out the value of x naught. So for this, what we need to do? Now again, you check the option, which option is going to match. Everywhere it's given in terms where m is divided here. Let's see, let's try to approach kx naught. If I make the subject kx naught, this will be written as mg minus L by 2 a sigma g. This is what we are going to get. Finally, x naught, if we write, that will be equal to mg by k, and here you can write L by 2k a sigma g. This is what we can comment. Now you see that at everywhere outside you have mg by k, so we need to take mg by k outside as common. So this will come out to be mg by k, and 1 minus this k we have taken outside, it will become L a sigma. Now see here you had mg and g you have taken outside, so it will not be a problem, and here you have to take 2 and you have to divide by m. L is sigma by 2m. So finally the result that you are going to obtain for x naught, that will be equal to mg by k 1 minus L is sigma by 2m. So mg by k, this is incorrect, mg by k 1 minus L is sigma by m, so but 2 is not here, incorrect. Mg by k 1 minus L is sigma by 2m, correct response. D, mg by k 1 plus L is sigma by m, incorrect. So now if you know accordingly how to proceed, you can easily score marks in your examination. Now you would be having an idea what kind of question and how you have to approach in such kind of question in your examination. Okay, now next thing, I believe that you have understood. If you want a quick recap how to do, you just check the entire scenario, construct the entire scenario, frame the equations. It's very easy for you all to get marks upon such question. So we got this answer which is matching with option number C. Let's go ahead with the next one. Next question of the class we have question number 2. A thin uniform cylindrical shell closed at both ends. You have a uniform spherical shell. The cylindrical shell, that means it's a hollow shell. Closed at both ends, is partially filled with water. Partially filled with water. So remember this term, partially, it's not completely partially filled with water. It is floating vertically in water in half submerged state. Floating in water in half submerged state. If rho c is the relative density of the material, rho c is the relative density of the material of the shell with respect to water, then the correct statement is that the shell is A, more than half filled if rho c is less than 0.5, B, more than half filled if rho c is more than 1, C, half filled if rho c is more than 0.5, and D, less than half filled if rho c, that is the relative density of the material, is less than 0.5. Check this question. It's not easy to derive to the result if you just observe the statement of the question. You have to think it accordingly. Now, first of all, what I will advise you all, construct a hollow cylinder and think that how you can go ahead with this question. If you construct a hollow cylinder, it will be having two portions as shown. Let me show you with different colors. You are having this as the hollow cylinder. So we have got this as the hollow cylinder. Inner part and outer part. Now this part is solid. Try to understand, this part is solid. So we got this. Now you see here how to approach. There are two volumes you can think of. Volume V1, let's say we are writing V1 is the volume of material of which cylinder is made up of, volume of material of cylinder. and let's say V2 is the inner volume of this cylinder. V2 is inner volume of cylinder. Inner volume of cylinder is V2. Next, inner part is actually filled with water. You see here, thin uniform cylindrical shell, we made it. It's closed at both ends, is partially filled with water. It is floating vertically in water in half submerged state. It's partially filled with water. So let us say this is filled with water up to some height. Now it says that it's floating in water. It's floating vertically in water in half submerged state. So this entire system is floating in water in half submerged state. That means somewhere here you have to mark that it is half submerged. I believe that don't confuse with colors. Let me show you with different colors. Already we have used here different colors. So what I will do, I'll use this color. Now it will be clear to you all. The only thing that we are left, we have to just equate the forces because no net force is acting on this, it's in equilibrium. Now the entire downward force will be equal to entire upward force. Upward force will be equal to the buoyant force that you can think of. Now buoyant force, now before that, net downward force is equal to buoyant force. As per Newton's second law, we can write net downward force is equal to buoyant force Fb. The downward force would be acting along the downward direction. Now see, let's say x part or the fraction x of the volume is, of the inner volume is submerged. That is filled with water. I'm sorry, that is filled with water. X, it is fraction of V2 filled with water. You will understand as I elaborate. So now you must be having that x into V2 will be the volume of water that's contained in. So now net downward force, you can write net downward force will be equal to the weight of this cylinder. Weight of this material will be V1 into rho c, that is mass, into gravity. V1 is the material volume, its density is rho c because if we take water density as 1, so automatically the density of cylinder will become rho c. So V1 into rho c into G plus weight of water, that is x into V2, that is the volume, into density, that is 1 into gravity. So we got this x into V2 plus into 1 into G. Now see this statement. It's floating vertically in water in half submerged state. Half part is submerged, half submerged state is equal to, now half of it is submerged, that means V1 plus V2 by 2. You have to take the entire volume will be what? It will be V1 plus V2. So V1 plus V2 by 2 and this you multiply with 1 into G. I believe that you can see up till this end, that will not be a problem. Now this, why I have taken V1 plus V2 by 2? Because this total volume will be V1 plus V2. Half submerged, so V1 plus V2 by 2. So V1 plus V2 by 2 into 1 into G, we got this. Check the option on what we have to comment. We need to comment on that the correct statement is that the shell is more than half filled. That means we need to compare the x value. More than half filled if rho c is less than 0.5. More than half filled if rho c is more than 1. Half filled if rho c is more than 0.5 and less than half filled rho c is less than 0.5. So we have to find out the relation between x and rho c. What I'm going to do, I'm going to rub the upper part which I believe that you would have taken down. So let me rub this part and let me rub this part also. We need only this equation. X we need to comment on. Let's go ahead and let's find the value of x. So x into V2 into G, and G is everywhere, we can cancel out. So G I'm cancelling out, we're getting x into V2 is equal to, that will become V1 plus V2 by 2 minus V1 rho c. V1 plus V2 by 2 minus rho C into V1. Now you see what you can get from here. You will be getting x into V2 is equal to, see here, can we write this as, take V1 common, can we write this as V1 and 1 by 2 minus rho C, so 0.5 minus rho C, we can write this, plus V2 by 2, not a problem, we can write here. Next you see for the value of x, you can write this as x is equal to V1 by V2, we got this, 0.5 minus rho C plus 0.5, because V2 will be cancelled out, so you will be getting plus 0.5. Now you just see the first option. It's more than half filled if rho C is less than 0.5. If rho C will be less than 0.5, you see here, if rho C is less than 0.5. So what we will getting? You will be getting this term as less than 0.5. You will be getting this term as positive. Positive term is this, multiply by this a positive value. You will get a number, positive number you will be getting, and plus 0.5. That means a value that's higher than 0.5. That means the fraction x is higher. That means more than half of the shell is filled. That means option number A, more than half filled, is more than half filled if rho C is less than 0.5. Yes, this is right. Once again, if you want, you can analyze on your own. Think here, if rho C is less than 0.5, this term will be positive. Understand? Let me write here. If rho C is less than 0.5, this term is going to be positive, and if this term is positive, so entire V1 by V2 into a positive value will give you positive plus 0.5. That means a number higher than 0.5 you're going to get. That means the shell is more than half filled. So it's more than half filled if rho C is less than 0.5. Correct answer. B, more than half filled if rho C is more than 1. If rho C is more than 1, you are going to get a negative value. So again, you are going to reduce it from this. So it will not be more than half filled. So this option is incorrect. C, half filled if rho C is more than 0.5. Not a possibility. We have already checked, it's more than 0.5. Then it cannot be more than, it cannot be half filled. Because for half filled you need to be this to be 0. The rho C should be equal to 0.5. Because rho C is more than 0.5, it cannot be half filled. Less than half filled if rho C is less than 0.5. This is just reverse of the option number A. We have already checked option A is correct, so this will be incorrect. So I believe that you have got how to choose. Very good question. Option number A is the correct answer for this. I hope that this is a very logical question and you have to analyze it. You have to proceed as per the equations and then you have to comment on the values that you obtain. And in JEE, questions come of such thing, of such values, of such method, you'll be getting questions. This is a good question. I believe that you have understood how we have proceeded with each of these steps employed. Next question, question number 3. A homogeneous solid cylinder of length L and cross-sectional area A by 5. We have length L and cross-sectional area A by 5 is immersed such that it floats with its axis vertical at the liquid-liquid interface with length L by 4. So here you see its length L by 4 is at the bottom part and length 3L by 4 will be in the upper part. In the denser liquid as shown in figure, the lower density liquid, that this is one, the lower density liquid is open to atmosphere having pressure P0, then the density D of solid is given by A 5 by 4D, B 4 by 5D, C 4D by 4D only, and D T by 5. How to proceed? It's given that homogeneous solid, its length is L, L by 4 is in the denser liquid, so this is length is L by 4 and this length will be 3L by 4. A by 5 is the area of cross section that has been given. Immersed such that it floats with its axis vertical at the liquid-liquid interface with length L by 4 in the denser liquid. As shown in the figure, the lower density liquid is open to atmosphere. This is open to atmosphere having pressure P0. The density D of the solid is given by. Let me show you with the diagram. We have two liquids, one liquid of higher density, one liquid of lower density. We have an object that is in this manner. This length is given as L by 4, so automatically the other length will be given as 3L by 4. The density of this is given as 2D, the density of this is given as D. So now if I just show you these two liquids, and here I am using a different color. I hope that you would have understood how to do this. Again, the net downward force will be equal to the net upward force due to both these liquids. The net downward force, let me write down, net downward force is equal to the buoyant force. Downward force will be automatically to be only to the weight of the body, and let's say its density is given as capital D. So density D into volume, that is length A, into area of cross section A by 5. We got the volume, then we got the mass, and after that multiply with G, net downward force is equal to buoyant force. Due to the upper liquid, it will be 3L by 4 multiply with area of cross section A by 5. So we get the volume of the upper part and multiply with density D and into G. Plus due to lower part, it will be L by 4 multiply with area of cross section A by 5. Then you will be having 2D multiply with G. This is what the terms that you will be having. Some terms can be cancelled out that we can see. First of all, you see G will be cancelled out. And we can easily cancel out A by 5 everywhere. Area of cross section is same everywhere, so A by 5 can be cancelled out. Now L is here, L is here, L is here, that can also be cancelled out. So L, L, L we cancelled out. From here you are getting D is equal to 3 by 4 small d, plus you see here 4 is here and 2d is here, so you will be getting d by 2 plus d by 2. This is the term that you are going to get. L by 4, so you will be getting here 2d you are going to get, so you will be getting d by 2. From here if you comment, this will come out to be 5 by 4d, 3 by 4d plus d by 2, you will be getting 5 by 4d. This is the value of the density of the solid object that's been immersed. 5 by 4 small d, we got it as per the equation. Let's go ahead. A option 5 by 4d, correct. B, C, D, B all incorrect. Proceed as per the given statement in the question, you will get the right result. All these questions have been asked in your previous examination. Hope this will let you to know what kind of questions do come in your examination. Now after this, we'll proceed with the next one. Let's go ahead with the next question of the class. Question number 4. A cylinder of mass m and density rho, again a cylinder, mass m and density rho, hanging from a string is lowered into a vessel of cross-sectional area S containing a liquid of density sigma, which is less than rho, until it is fully immersed. The increase in pressure at the bottom of the vessel is A, m rho g by sigma s, B, mg by s, C, m sigma g by rho s, and D 0. For this question, what we are going to do, we are going to apply the method. This is the case. There's a container. You have taken a cylinder, it's completely immersed. You have taken a cylinder and it's completely immersed here. Now it says that the increase in pressure. How to proceed with this? The increase in pressure at the bottom of the vessel. We need to find out increase in pressure. So pressure is equal to force upon area. So how much force is exerting? It's not touching it, but still we need to find out how much force it's exerting. First of all, let me find out the buoyant force that will be acting on it. Buoyant force will be due to the liquid, and that will be the volume of the cylinder multiplied with sigma, that is the liquid density, into G. We will be having this. Its volume for it, its cylinder mass is m and density rho. So automatically its volume will be m by rho multiply with, remember FB I am writing for buoyant force, multiply with sigma into G. So we got this. The buoyant force equal to m by rho sigma G. Now if this much force is exerted on the object by the liquid, from Newton's third law, the same amount of force will be exerted on the liquid by the object. So from Newton's third law, we will be having the same amount of force will be acting on the liquid. Force acting on liquid will be equal to of same magnitude. Force acting on liquid, that will be equal to m by rho sigma G. So force we got. Now you see here the increase in pressure at the bottom of the vessel is increase in pressure just divide by its area of cross section, that is S. So increase in pressure that you will be getting, that will come out to be delta P is equal to force upon surface area, that is given as S. So m sigma G divided by rho into S. This is the answer, m sigma G by rho into S. Let me encircle this part, m sigma G by rho S. Let's comment on the value. M sigma G by rho S, and here we have m rho G by sigma S, so incorrect. And here we have m sigma G by rho S, C option is correct, mg by S incorrect, 0 is incorrect. Sometimes you may be thinking that mg by S will be the answer. It's force upon area mg by S, but no, you have to think accordingly. This is the answer as we proceeded, and we got this m sigma G by rho S. Hope that you have got to know. Very good question, and this would let you understand a different kind of concept that can be used in this chapter. Things are same, but the method in which it is represented, that is changed, and a new question comes. Let's go with the next question of the class. Question number 5. A ball of mass m and density rho is immersed in liquid of density 3 rho. Now we have a ball whose density is given as rho and mass m is immersed in a liquid of density 3 rho at a depth h and released. To what height will the ball jump up above the surface of liquid? Neglect the resistance of water and air. A h, B h by 2, C 2h, and D 3h. Very good question. You see here, you have a liquid and its density is given as 3 rho. And in this liquid we have taken a ball to a height h. Next thing, you see here, it says that what will happen first? The density of two are different. The ball of mass m and density rho is immersed in a liquid of density 3 rho. Ball density is given as rho, and the liquid density is given as 3 rho. So first of all, a net upward force will be acting on the body. Let's find out the net upward force. Net upward force acting on the ball will be buoyant force minus its weight. Buoyant force will be how much? It will be volume into density into gravity. So volume will be given as its mass m by its density m by rho, that is what we know. Volume into density of liquid, that is 3 rho given, and into gravity minus its weight mg. So you will be having this as 3 rho, now you see mg, and you will be having 3 mg minus mg, so it will come out to be 2 mg. This will be the value of net upward force. So let me write this as F net. For this acceleration, you will be getting F net by mass. This will come out to be 2g. So while it is moving up, the acceleration produced is equal to 2g. First thing we got. So if it starts its motion from here with an initial speed u is equal to 0, the speed that it is going to attain at this point when it travels a height h with an acceleration of 2g, let's try to find out its speed. So use the formula v square is equal to u square plus 2as. So here v square we need to find out the final velocity. Initial velocity is 0, 2, value of acceleration is 2g, s is h. So v will come out to be under root 4gh, that is 2 under root gh. This is the value of v. The velocity at this point, that means the velocity at this point when it reaches, that will be equal to 2 under root gh. The maximum height that it topples, that it reaches here, we need to find out this. Let's say this is capital H. This is the thing that's required. What height will the ball jump up above the surface of liquid? We need to find out this. Initial velocity is given as this. Now I believe that you can use the formula. As it moves up, d acceleration will be acting on the downward direction, and that will be g. So again using v square is equal to u square plus 2as, and in case of d acceleration, so minus 2as, where a is g downward. So from here, velocity v is 0, u is u square. If you do, you will get 4gh minus 2g, and the value of s will be h. So from here, capital H will come out to be 2h. You just check, capital H will come out to be 4h divided by 2, you will get 2h. A good question. H equal to 2h we got. This is the height that it will be toppled. It will be toppling. So option number A, h incorrect, B, h by 2 incorrect, C, 2h is the correct answer, 3h again is the incorrect answer. I believe that you have got to know how to solve such kind of question. It's a very good question, and such kind of question do come your examination. So hope that you have learned a lot with this exercise, what kind of questions do come your examination. What I will advise you after this class, also practice questions on your own. That would be of great help to you all. Learn the entire concept, revise the formulae. Some basic formulae you need to by heart, like terminal velocity, surface tension, all this formula, Bernoulli's equation, all this formula you need to by heart, and rest you all need to practice questions so that you can understand how to apply those understanding and learnings. That is advisable to you all. So I'll request you all do practice questions after the class, and I wish you all the very best. Thank you for joining me here.